We have another trig one here. If we use direct substitution, we get 0 over 0, so we need to split things up. Before we split things up completely, we need to write them in terms of sine and cosine. So I'm going to rewrite this as limit as x approaches 0 of sine of 2x over cosine of 2x, all divided by sine of 8x divided by cosine of 8x. Now we can go ahead and change this from dividing by a fraction to multiplying by the reciprocal. We get limit as x approaches 0 of sine of 2x over cosine of 2x times the reciprocal of this denominator, so we get cosine of 8x over sine of 8x. But now we need to go ahead and split everything up. So we have limit as x approaches 0 of sine of 2x times 1 over cosine of 2x times cosine of 8x times 1 over sine of 8x. So remember, the cosines, we don't have to worry about those, because if we approach 0, we're approaching cosine of 0, which is just 1, so that's not a big deal. The sines, though, we have to take care of. So for the sines, we're going to go ahead and make sure that they have sine of u over u, or u over sine of u. So in this case, we need a 2x on the bottom. We can multiply the bottom by 2x, but we're going to have to multiply the top by 2x also. Cosine's fine, cosine's fine. Another sine one, we need an 8x on top, so we multiply that, and then 8x on the bottom. Then our x's cancel out, and we can go ahead and evaluate each of these parts. So we have 5 parts to this limit. First part, limit as x approaches 0 of sine of 2x over 2x, that's just going to be 1. Limit as x approaches 0 of this. This one we're actually using direct substitution. You get 0 in here. Cosine of 0 is 1. 1 over 1 is just 1. Cosine of 0, again, is just 1. Here we have u over sine of u. We know that one's 1. And then here we have a constant. Sine of constant is the constant. I'll just simplify it here to 1/4. So our answer for this one is 1/4.